Hello and welcome to XNA. What is this? Part 1. In this series I will be making in-depth descriptions about different stuff found in XNA. There will also be some details about C# stuff. And just a heads up, this is not a tutorial about how to make something cool in XNA. I'm not going to show you how to make a neat effect or animation. I'm just going to describe all kinds of possibilities you have when making games with XNA. So, this time we ask, what is a SpriteBatch? SpriteBatch is our main tool whenever we want to draw stuff on the screen. We always need to create a SpriteBatch before we can use it, just like with any other objects. And here I have my default game project, and I've added 2 textures here and already made some drawing calls here. And let's go to our load content method. Here I have the texture load calls, and here I have my SpriteBatch initialization constructor call. And we basically have only one constructor method, which is new SpriteBatch with argument to our graphics device. This creates a new SpriteBatch which uses our default graphics device. It means that the SpriteBatch is initialized for our graphics device and it should be ready to draw stuff on our screen. In some cases you may have multiple graphics devices and you can choose the correct one by setting the argument to the one you want. Now that you have the SpriteBatch, we can use it to draw sprites on our screens. All the drawing related method calls are placed inside the draw method of our game class, which is here. And the begin method here is the one you always call whenever you start drawing stuff. We have multiple overloads for this method and we have to choose the appropriate one for our drawing needs. If you don't really care about blending, sorting and that kind of stuff and just want to draw something quickly on the screen, you can use the begin method without any arguments, like this. So let's begin with our SpriteBatch.begin's 7-argument version. The first argument is sprite sort mode, and this tells the order of our sprites we draw. And here we have a couple of options. We have, for example, sprite sort mode .back to front. And this means that we begin drawing stuff from the back to front with our layer values set for each draw call. We're not going really that deep into that just yet. We handle that in the draw call. And likewise we have the front to back, which just draws stuff from the front to back. First front, then back. Simple as that. And now you may wonder which one of these I should use. The answer is, if you have sprites that have transparency, you should use back to front, so the transparency effect will work as intended. Sometimes you may have the need for front to back, but I usually just use the back to front one. And of course, you can select one of the other sort modes as well. The deferred here means that the sprites are not drawn until you call the end method here. So this is the default setting, and actually the back to front and front to back modes use this as well. They just order the sprites before drawing them. This deferred mode doesn't do any depth sorting, so you cannot be sure whether or not your sprite is drawn on top of another sprite. So you have to manually set all the depth values. Then we have sprite sort mode .texture. This is just about the same as deferred, but it sorts the sprite by texture. This means that there is no real depth sorting, but it offers some performance boost when there's no overlapping sprites. This is usually good if you are drawing 3D scenes, which are first drawn on rendered targets and then drawn on the screen with the SpriteBatch. And the last one of sprite sort modes is the immediate mode, which draws the sprites on the screen right when you call the draw method here. Like first you call this, the sphere is drawn on the screen, then you call this, the square is drawn on the screen. Not like with the old deferred mode where you call these draw methods, nothing happens, but when you call this end method, it draws all the sprites at once on the screen. So, when you use immediate method, the sorting happens pretty much like when using back to front method, but you can only use one active SpriteBatch instance, otherwise you will run into conflicts. I don't really know any meaningful uses for this mode, but if you think you need it for your project, it's here and you can use it. So, let's set this one to back to front, and the next argument is blend state. This one tells how to blend stuff that is overlapping. We have, let's see, blend state.additive. I can't really pronounce that. Additive, I guess. This is the first one, and it adds the values without doing any alpha multiplications. Damn, I have really much trouble pronouncing these words. Nevertheless, additive should do this without any alpha. So let's test this one out. We have blend state.additive, and we have two sprites that are overlapping. Woo! That looks pretty funky, I guess. So, that's what you get with blend state.additive. And the next one is alpha blend, and this uses your sprite's alpha channel to blend it with other sprites or the background. This is the most useful and most used one, and I'm guessing you're looking for this one too. So let's test that one out. There we go, it's the basic one we want to use. So the next one is non-pre-multiplied. This is almost like alpha blend, although it blends the colors, but it assumes... What? Let me start that one again. Non-pre-multiplied is almost like alpha blend, and although it blends the colors, it assumes that the color data doesn't contain any alpha information. There. Let's test that one out. It looks just about the same because I don't have any alpha information in my colors. And the last one here we have is opaque. This is the old school mode where the new data or color completely overwrites the old one. No blending is done whatsoever. Let's test that one out. And here we have, there's no alpha channel here. Great. So yeah, let's put alpha blend here because we want to use that. And the next one is sampler state, and this one tells how the texture should be sampled. For example, you can set the texture to repeat itself, or you can change the UV scale or the anisotropic or linear sampling, whatever you want. You can actually construct your own sampler state like this. And it's set like address U is texture address mode mirror. This will mirror your texture on the U scale when it tries to repeat the texture. We're not going really that deep into the sampler state, because if you really need this stuff, you already should know what you need. Let's just put here sampler state anisotropic lamp. There we go. The next one is depth stencil buffer, and this one sets the depth stencil state for the SpriteBatch. Damn, that's a hard word to pronounce, but I nailed it. The depth stencil is basically an integer array for each of the pixels on your screen, and it determines which pixels should be rendered and which ones should not. If you set this one to let's see, def stencil state dot default. The depth stencil buffer can be both read and written on. If you use depth read setting, it can only be read, and if you use depth stencil state none, it's not used at all. We can test this one in just a bit. We just need to give one more argument, which is rasterizer state. And let's see, let's use the default call counterclockwise. I will go deeper into this in just 1 second. So let's test the depth stencil state dot none first. Does it really affect our scene? Nope, not really. And let's test default. Nothing. Actually, this doesn't really affect your 2D scene, as you can see. It's useful in 3D scenes and stuff like that, so I guess I'll leave it for the later purposes, when we actually need it. And rasterizer state is actually one of these as well. I think it shouldn't affect anything if I just... Oh yeah, it does. Yeah. So, my mistake. The rasterizer state sets the culling method, and culling is the method of removing polygons that are not visible, and that is done for performance purposes. This basically means this sets the culling direction, whether or not we are culling clockwise, counterclockwise, or not culling at all. And the default one is call counterclockwise, which means we are seeing these ones, and if we set it to call clockwise, it doesn't show. Because now in this version the sprites are actually drawn on the other side. So imagine you have a piece of paper in front of you and you have little drawings on it, and you just rotated the paper in a way that you can only see the backside of the paper. So the pictures and images and sprites are there, they exist, but you can just see them. And let's test in call none. There we go. Now this happens if you use like water paint on your paper and the water just goes through the paper. You can see the exact same image on both of the sides of the paper. So let's put this to the default call counterclockwise. There we go. And we have 2 more arguments to go. The next one is effect. Now, if you have a shader for your SpriteBatch, you can call it here like my cool shader effect. But I guess we don't have any, so you can just set it to null. This means that we don't use any shaders. And the last one is our transformation matrix. And you can use this one to move or rotate all the stuff on your screen at once. And this actually sounds more difficult and more complicated than it really is. But basically this is useful when you're making a game where you want to scroll your screen. For example, a 2D platformer. So let's make a matrix.identity. Identity matrix just tells that we have matrix that doesn't do anything. So it should, yeah, it works just like before. Let's see, let's make a matrix.create translation and new vector 3. Let's put 300 0 0. Let's see what that does. Yeah, Now you can see that all the objects on the screen just moved a bit to the right. Or you can actually think, which is the more better way to look at it, the camera just moved to the left. Cool. Yeah, that's basically all the arguments for our begin method. So let's go to our draw call here. These are just the basic 3 argument versions of our draw call, but we can actually change these a bit. Let's comment out the sphere and type a new one here, SpriteBatch.draw. So let's take this one. Here we have texture, destination rectangle, source rectangle, color, rotation, origin, effects, and layer depth. And let's see, our texture is the sphere, and this is the texture for our sprite. This can be the whole sprite sheet if you have like a image that has like 30-40 little sprites. It doesn't matter here, you can just use the whole picture here. We can take specific parts of it later with destination rectangle and source rectangle. Now the next part is the source rectangle, and this is the these are the coordinates we want to place our sprite on the screen. So rectangle works like this. First we give the x coordinate for our top left point of our sprite, and let's see, we want to draw it to 150, and then we give the y coordinate, which is 100. And then we can give the width and height of our sprite. For example, we can put 32, 32 here, and we get really small. And let's test that one out. We should have, yeah, very small sphere. And yeah, the next argument is the color. This is the tint of our sprite. Actually, whoops, let's go to the this one. The next one isn't color, but the next one is a source rectangle. This tells which part of the texture we should use. You can set this to null if you want to use the whole texture, or you can set it in texels, and which means a range from 0, 0 to 1, 1 is the whole texture, while 0, 0 to 0.5, 0.5 is the range from top left of the original image to the middle of the image. So let's make a new rectangle here, and let's type 0, 0 and 64, 64 or 50, 50. There we go. And let's test that one out. There we go. We have the top left part of our sphere image there. So we just grabbed a little piece of our sphere image, the original, and we draw it on the screen in these coordinates with a size of 32 times 32. And if we... Actually, these aren't texels. My mistake. These are pixels. Whoops! Well, doesn't really matter. We can actually change these values from 0, 0 to 50, 50, and it should show the... Yeah, now it shows the middle of the sphere. There. You can't actually tell, but it's a sphere originally. Yeah. Let's move on. The next one is color. And this is the tint of our sprite. If we use white color, it doesn't tint the sprite in any way. But let's say we use color dot medium violet red. It should tint the, yeah, it tints the sprite a little bit. If you use color values without any alpha, you might actually get, I'm not quite sure about this, but you may get fully red or fully green images. Let's just reset that to white. The next one is rotation. This is the rotation of our sprite around the z-axis in radians to counterclockwise. So if we just actually rotating a sphere is a bit difficult, but we can actually test this. Let's put 2F here, and I'll just reset these ones like this, so we can test that one. Yeah, now it's rotated 2 radians counterclockwise. Actually, it worked. I thought it would be rotating the original, but it rotates the final output. There we go. And of course, if we put minus 2F, it rotates it to different angle. Cool. We can actually set that to 0, and the next one is the origin. This sets the origin, which is by default the top left corner of our image. We can set this to, let's see, vector, new vector 2, and sphere dot width divided by 2, and sphere dot height divided by 2. Now the origin of the image is right in the middle of the texture. And let's see, now if we rotate it by 1F, it shouldn't just travel, it should just rotate around the center point, which is actually does right now. Cool. This is quite useful if you don't really want to position things according to the top left corner, but instead you want to place it along this center point of your object or texture or sprite. So, 2 more to go. The second to last is sprite effects. This defaults to none, which does nothing for the sprite. If you set this to flip horizontally, you get a horizontal flip for your image. Actually, you can't really see that, but it's there. And same thing if we take the flip vertically, it flips it vertically. Cool. And the last one is the layer depth. This tells the depth of this sprite, and it's between 0F and 1F. And we can actually test this one out. Let's edit this SpriteBatch.draw square. Whoops. Let's add more arguments here. Let's set this one to null and this one to color.white. Rotation to 0F. Origin to vector.0. Sprite effects.none. And let's see. Our sphere is 1F layer depth and our square will be 0F. Now, what? New vector. Let's see. New rectangle. 200, 200, 120, 120. There we go. Here we have our square and sphere. Now, let's take the sphere's source rectangle out and let's resize it a bit. There we go. And let's reposition our sphere a bit. Okay, they are, well, let's move them just a little bit so they overlap a bit more. There we go. The square is drawn on in front of the sphere. Cool. And we can see here we have the back to front, and square is drawn in front of the sphere because we have the 0f here and 1f here. If we exchange these and this, now the sphere is drawn in front of the square. Simple as that. And I guess now if we don't touch those values and we change this one to front to back, this happens. I guess this isn't that welcome thing to happen, but as I said earlier, you shouldn't use the front to back version if you have transparent images. So let's change it back to front, and you must change these ones back if you want to draw the square in front of the sphere. So basically, the sprites which have the 0f depth value are drawn closer to the screen, and the ones with a value close to the 1f are drawn behind the object, further away from the camera. Cool. And the last one I'm gonna talk a bit is the SpriteBatch.drawString. This is actually just like the SpriteBatch.draw, except that instead of a texture you give a sprite font here. I just type null. Then you type text on the screen. Then you give a position for the text, and finally you give a color for your text. And of course you have multiple overloads for this one. You can give rotation for the text, scale, sprite effects, all the same arguments that we have with the basic draw method. This was What is a SpriteBatch by GDVlog, and thanks for watching.